Welcome back from the breakout rooms. I know there's a lot of activity and a lot of energy, and a lot of you all want to share your bridges. And we have the amazing Jerry Dawes here, who's going to be leading this wrap up session. So I'm going to stop speaking because we only have 30 minutes for the wrap up. And I know he wants to introduce himself. And so, Jerry, you can take it away.
Thanks a lot, Monica. And I want to say a special thank you to the entire team for making today possible. Really excited. I want to say thank you to the ET staff. We had presentations by Edgar, Dylan, Bryce. There are a number of folks who worked in the background, Jen, Constance, Betsy. I also want to say thank you to the teachers. And I want to say thank you very much to the students. You are the reason we are here. And we're here to do the wrap up. So in the next half hour, we want to see all these great designs that you've come up with. So without further delay, as Monica mentioned, my name is Jerry Dawes. I'm one of the staff engineers at Engineering Tomorrow. What I have just a couple of slides that I have to guide our conversation in the wrap up. If you could see my current slide, it's all about bridges, how structures connect communities. Before I move forward, just want to give you a little bit of background about myself. So I'm coming to you from New York City. I'm a New York City resident. I attended high school and college in New York City. If you could look at the chart under the education tab, you can see I've attended the NYU Tandon School of Engineering, which is located in downtown Brooklyn, New York. I majored in electrical engineering. I have a Bachelor of Science and a Master of Science degree in electrical engineering. And once I graduated, I went to work for a large energy company by the name of Con Edison Company in New York. I've worked there for over 30 years, working with teams of engineers in basically developing and providing electricity to customers all throughout New York City. With Engineering Tomorrow, I'm a staff engineer, which means I'm responsible for developing and delivering exciting labs like what we're doing today. And my interest in engineering is primarily around renewable energy. As I said, as an electrical engineer, basically what I did was worked on delivering electricity to customers. And now there's a big transition going on as we kind of move away from using what are called the fossil fuels, coal, oil, natural gas, and we're transitioning to the use of wind and solar and a lot more renewable, cleaner, greener energy sources. That's what my background is all about. And now we get to hearing from you. We want to give as much time as possible to have all the various schools present. And so, on this slide here, I just want to call your attention to the diagram in the lower right-hand corner. I know Edgar reviewed this morning. It's called the engineering design process. And I know many of you have applied this to developing the bridges that you've put together. And let me just quickly walk through it. We'll typically start with the arrow that says design. You've sketched out kind of what you want to work on. You come up with an initial design, then you move in a clockwise direction. You design, you build, you test, you deploy. And very importantly, learning from the process. Many times as engineers, we don't get what we want on the first attempt, the first iteration. So on this learning step, we ask ourselves the question, did we accomplish what we were asked to do? So we were asked to develop a bridge. There were constraints. You got to take the compression and the tension forces into account. Did it work? Were we able to test it with weights? Did it hold up? And then if it did not, if there were any kind of breakpoints, we go back to the drawing board. We go back to the design, and then we make modifications accordingly and go through the process again. This is called an iterative process, meaning many times we have to take several iterations before we get it to work. So keep that in the back of your mind. That's kind of the process we use. So now let's go. Monica,
I think, Jerry, if you could stop sharing your slides. I see one of our schools, Middle College High School in Memphis, Tennessee. I see their students are standing around a bridge. It looks like they're getting ready for a test. Are you guys ready to chat with us? I'm going to spotlight you for everybody. If you can unmute and let us know, they're testing.
Wow.
They're ready for a test. They're live testing. Can one of you guys unmute and let us know what's going on? How much weight is in that bag? Here comes a teacher.
Okay, yes, we are. Did I click out of it?
No, we can hear you. We can see you.
Yeah, we're presently testing. We're testing. We're running the test now.
How much weight is in that bag?
That's a good question. How much weight?
It's 5
pounds.
Put another one.
All right, they're adding some weight, Jerry. What do you think? You think it's
No,
gonna take another
it's
5
looking
pounds?
great. I love the design, symmetrical design, looks fairly sturdy. You know, we're gonna see the break point.
Here we go.
Here we go.
Wow, we can see.
It held it.
I don't know if it needs to sit on there.
It didn't snap. Boy, we never had a bridge.
I think we need to know where to stop on the weight.
Jerry,
So they're 5 cans so far. So, all right, so maybe let's try one more.
One more.
Say, try one more.
they're afraid for it to break, Jerry. They don't want it to break.
So let's see.
Okay, here comes, how much is that? 5 more pounds? It's a 5 pound weight.
Let's see. We saw some deflection. Let's
Yes,
see
we
how
did.
much happens now.
Is it,
No, it held up, but we can see, yeah, we definitely saw some deflection there. So, all right, so I want to give a round of applause to the team at Middle College High School in Memphis. Excellent job, everyone.
Oh.
Yeah.
All right. Is there?
Great
I
job.
see that they're continuing testing. Is there another group that's ready to share? Highland Park, are you guys ready?
Yes, we are ready to share.
Fantastic. I'm spotlighting you so we can see your classroom. Hi.
All right, hi. So we have one group over there. We're using sand to test. So
All
they're
right.
measuring out the volume of sand that they're putting in the pail. And they're testing their bridge right now. I have a bucket underneath for, mess cleanup.
Okay.
So
Highland Park is prepared.
Yeah, we can see that.
Second so they can see the bridge. So there you see the bridge and they're adding sand to the bucket
Nice.
and figuring out the volume of each sand that they're adding to the bucket, and it still hasn't dabbled. So guys, what volume you have so far?
I know they're interested in the testing, but can one of them come up and talk to us about how they designed their bridge? Anybody want to come up to the camera and talk with Jerry about their bridge design?
Sure.
Anybody?
They're,
Yes.
they're,
Anybody?
they're
Come on
all
up, don't
very,
be shy,
they all
don't
want
be
to see
shy.
the testing. I know, but come on up and chat with us.
Could you give us your name, please?
Hi, my name is Kai. Why do I have a filter on me?
He has a filter on, which is why he's asking. Hold up, I don't know how to take my filter off. Hold
I
up.
guess I just have lipstick now.
It's all right, Kai, you look great.
All right, so Ty, give me the names of your other team members.
My team members are Elias and Aaron.
All right, okay. All right, so talk to us about the bridge design that you came up with.
Well, our base was made up of 2 medium dowels and 1 large dowel, and then we took small pieces of popsicle sticks and laid them on top, so it kind of looks like a railroad track.
Okay.
And then the sides are made with popsicle sticks forming like equilateral triangles. Because equilateral triangles would be the strongest shape that we could make.
All right, were there any particular challenges that you had to overcome as you were putting it together?
I think everyone's laughing at the filter. I think that it was challenging to figure out like what to use popsicle sticks for and what to use dowels for, because the dowels were longer, so we wouldn't have to connect things together and worry about them breaking at the connection points. But also the dowels were less strong because they're thinner.
Also, sometimes the beams were equally spaced. We had to use some tape when we couldn't glue.
Yeah. Because there's also difficulty sometimes with spacing, so we had to alternate between using hot glue and tape to put it together.
Excellent. How many iterations, how many attempts did you have to kind of go through before you got to this testing phase?
1.
Just one? Wow, that's great. That's excellent. Excellent job. All right, so how many, I see you guys are using like a bottle to take the sand and then for the testing, how many of those bottles have you used thus far?
How much sand? No, we're not using water bottles. We're using sand volume.
Right now we have 10.
So like we have 60 ounces of sand in there right now.
Wow. And it's held up so far?
Yeah, it's not bending yet.
Not bending. Wow.
That's
16
a strong
ounces.
bridge.
That's a really strong bridge.
Okay, I'm gonna turn off. How do I
Go ahead, Ty.
keep the filter on? Okay. Thank you.
All right, so Ty, I want to say thank you. We want to give an opportunity to some other schools. So round of applause for Highland Park High School.
Great job, Highland Park. I see Frederick Douglass. Are you ready? I see a bridge there on the screen. I'm going to spotlight you. Are you guys ready to share with us? Can we ask you to unmute and talk with us? They're backing
Come on,
away
don't
from the
be shy.
camera.
Don't be shy.
Look,
Yes, we are ready. I guess he's already midway through testing. He already has, how many bottles, Henry? 18 bottles in there, and I think that's the max our bag can hold.
No, stop.
wow.
Gonna add more? Okay, go ahead.
Sir, what?
Calm down.
We're gonna try to get it in there some kind of way.
The bag is at capacity.
Yeah,
That's like it's gonna fall apart.
yeah, the bags have been tearing. We need to get
Wow.
better.
So 18
All
water
right,
bottles,
so that's 19.
19.
I see the bridge is deflecting a bit, right, Jerry?
Yes, I can see it. Excellent. Could I have the names of the students on this team, please?
Go ahead, Henry. Who's on your team?
My name is Henry. What's your name?
My name
Henry,
is Smudge.
Samaj and Samantha. Yeah.
Henry, Samaj, Samantha. Did y'all have four? And Devin.
Excellent. Quick question. How many iterations, how many times did you have to adjust your design before you got to this testing phase?
I think about 2 to 3 times.
2 or 3 times. Okay. Were there any particular challenges that you had to overcome before you got to this point?
Making it durable.
Making it durable.
All right. And it looks like you did an excellent job in doing that. So it looks like you're up to like 20 bottles so far,
Yes.
Yeah.
and you're still holding. All right. I want to say thank you very much. Round of applause for Frederick Douglass High School. We want to give some other students an opportunity.
Great job.
All right. Great job, team. Thank
All
you.
right, let me remove the spotlight. Let's see, is there another group that's ready? I know there's a couple of groups from Middle College, but I'm not sure who's ready to share with us. If you want to raise your hand. No? American Senior High School, anybody want to share with us there?
Douglas is calling out Charles Flowers.
Charles
Wow.
Flowers. They are calling up, but Charles Flowers doesn't have their camera on. Charles Flowers, are you ready to share? Oh, American Senior High School is ready. Thank you, Constance. I am going to spotlight them. Hi, American Senior High School.
Welcome,
This is
American Senior. Who is the spokesperson? We need someone to come up and talk to us.
Oh, let's see.
And if you could just take take your mic off mute so we can hear you. Okay. All right. So who's the spokesperson? Could you give me your name, please?
Oh, look, we have 2 bridges.
Wow. All right. Could you give me your name, please? Yes.
Yes,
I'm
You
not
were-
hearing you.
I'm not hearing you. Let's see if we can get you to unmute.
We are muted.
Oh, okay, speak up.
His name is Samuel.
Samuel. How you doing, Samuel? All right. So who are your teammates? Who are your team members? Samuel, come back. Wow. Okay.
Here.
What's the name of? Okay. Give me the names of your team members. I can't hear you clearly.
Diana Lopez, is that correct?
Nayara Lopez.
Nayara Lopez.
Nayara?
Nayara Lopez.
Ayana, and who's the other team member?
Lisday Delgado.
Lisa.
Lisbeth.
Okay. All right. All right. So, all right, Samuel, if you could hold up the bridge, talk to us about the bridge. Okay, it looks very sturdy. How many iterations did you have to go through before you got to this point? Any particular challenges that you had to overcome?
¿Cuánto tiempo to make the bridge?
30 minutes. For 30 minutes.
No, like how many iterations?
Just one? That is excellent. So a really sturdy design, a really nice truss bridge. Your base looks really sturdy. Have you been able to test it with any weights yet? Have you tested it with weights? Okay, one. Okay. All right, great. Thank you very much. A round of applause for American Senior High School, please.
I think do you want to share, does the other team want to share that bridge
Yes, does
that's
the other team
standing
want to
there?
share? Could you give me the names of your, could you give me your name and give me the names of your team members, please?
My name is Alex.
Alex?
And I'm Juan.
Hey, excellent. All right. So talk to me about the bridge. How many iterations did you have to go through before you got to this point?
Well, we had a very hard time with the stability because it was tilting a lot, but we just got it with more sticks on the top.
Okay. Excellent, excellent. Was that the only challenge that you had to overcome?
So the floor, like the base, we had to make a different base because it didn't like everybody made a different base than us. So we used like duct tape and we like made it firmer like that.
Gotcha. Great job. Have you been able to test it with any weight so far?
Yeah, we managed to put, I think, 1 or 2 books on it.
Okay. And it's held up so far?
Yeah.
Okay, great. All right. I want to say thank you very much. American Senior High School, great job.
Great job. And I saw in the chat, Constance says that Charles Herbert Flowers is ready, but they don't have their camera on. Let's see. Anybody else want to raise their hand and share their bridge? I see a lot of movement on the cameras that are on, but I don't have anybody raising their hands.
Mr. Lynch, are we ready?
No cameras are on, so I can't spotlight them.
Hi, Vilma. Are you ready out there?
All right. Well, oh, Highland Park turned on their camera again.
Okay,
So light them.
What we did,
Yes.
we went and got kilogram masses. So we took the sand out because they had too much sand. We got up to 13.5 kilograms and then we went back and got some 5 kilogram masses. So each kilogram is 2.2 pounds. So
Okay.
you can do the calculations there. And they said they want to keep adding till it
Till it
bevels. So
breaks.
you guys up to right now. So the bucket comes in handy now because they're holding these heavy masses. But the bucket can't. And somebody's recording this too, because they want to see if it snaps. So we have these 1 kilogram masses, and we also have some big 5 kilogram masses. So I don't know from where this camera is. I'm gonna move the camera up. Whoa, what stepped out? No, I'm trying to unplug my phone camera so it moves.
Oh, we're on the move, Jerry. We're on the
Yeah,
move.
I see it. Yep.
Kilograms.
Got a close look. Look at that bridge.
Yeah, if you could adjust the camera down so we could see the bridge a little bit more, please.
No, it broke.
It broke. Okay.
What
All
is
right.
that?
28 kilograms.
28 kilograms.
Excellent
Yeah.
job.
Kilograms.
Round of applause for Highland Park High School.
Woo, and look, that bucket is.
Oh my goodness.
Wow.
We need to consider sending them some bigger bags or buckets for testing. Everything is at capacity. Amazing job.
Amazing job. If you could get us a copy of that video that you made.
Yeah.
Excellent.
He was videotaping it.
Okay, great.
Fantastic. I see Herbert Lehman High School has turned on their camera and I see a bridge. Are you guys ready to share? Can I spotlight you? Oh, they turned off their camera. Let's see.
Actually, the students are at lunch at the moment.
Oh no.
Okay.
But thank you for turning on your camera and showing us some of their creations.
All right. Yeah. They built.
Did they test them yet?
Yeah, we stopped at 50 pounds. They got up to about 50 pounds. So some made it and some didn't, but they did pretty well.
Excellent, excellent. I see that you've shown us two different designs so far.
Yeah, and some students just built kind of a flat bridge,
Light bridge, yeah.
which actually that did okay.
Mhm.
And then the kind of a lot of triangles did very well. That held 50 pounds and didn't break. We ran out of weights.
Wow, wow, 50 pounds, that's great.
This one was this one, I think, yeah, this one did great. I don't know how much it held, but they did pretty well.
Yeah, it
Okay.
looks very sturdy.
Thank you for sharing, Mr. Lynch.
You-
That's
you got it.
awesome.
Thank you, thank you.
All right, thanks, Mr. Lynch. All right, anybody else wants to share?
If you feel that you are ready to share, you can raise your hand in Zoom and we can get right to you. We have about 9 minutes left in our wrap-up session. So you have about 9 minutes if you want to share your bridge. And if not, Jerry, I don't know if you want to share the rest of your slides.
Yeah, if nobody else, let's give it another minute or so. If nobody else wants to share, then I'll go back and just wrap up the slides.
Yeah. I have to say, I'm so excited. I'm so glad we got to see some live testing, and it looked like the capacity was the issue. It was the bags couldn't hold the weight that needed to break
Yeah.
these bridges. They made some really strong bridges today.
Excellent, excellent job. All right, I'm not seeing any more volunteers. Sorry, I'm going to go back to sharing, Monica.
Yep, go for it. Oh, American Senior High School, are you waving us to share? Yes,
They are?
I saw a hand wave at American Senior, but now they walked away from the camera, so you can keep going.
All right. So, all right, can you see the screen?
Yep.
Okay, great. All right, so as in the final minutes, let's talk about careers. So obviously, this was a really exciting lab, got a lot of great energy, great participation. Let's talk a little bit about careers related to bridge building. And as shown on the screen, we have several different engineering disciplines that get involved with bridge building. So we've got civil engineers who get involved with the design, the structures. You got the materials engineers, the materials that are used, the architects, the design of the bridges, the mechanical engineers, all of the mechanical systems on the bridge. And I'm going to add one more, electrical engineers. I told you that my background is in electrical engineering, and I work for a large energy company by the name of Con Edison. In addition to all of those, what are called the, kind of the traditional uses of bridges for vehicular transportation, for traffic, for train traffic. In some bridges in New York City, we actually use bridges, the underside of the roadway, for carrying electric cables, which then transmit electricity from one part of the city to another. So there are many different uses for bridges. So bridges are very important. And this morning in the intro, Mr. Martinez talked about how it can change economics. So you can transport people, goods, equipment from one part of the city to another. So we have listed here a range of engineering disciplines that get involved with bridge building. So that's one piece of it. The second piece of it is, I know you're still in high school, you may not have yet decided what career path ultimately you want to pursue once you graduate, but to help you in that journey, we're sharing some information. So there's a government agency called the Bureau of Labor Statistics, and they have a website, bls.gov, www.bls.gov, Bureau of Labor Statistics. This government agency compiles a lot of information regarding compensation and salaries on a range of careers. So in this particular case, we were able to pull the annual average salaries of the different types of engineers that get involved with bridge building. So as shown on the screen, going from left to right, civil engineers making on the order of about $88,000 per year, materials engineers on the order of $93,000 per year, architects on the order of $80,000 per year, and mechanical engineers on the order of $88,000 per year. So in terms of determining or deciding a career path, it'd be great if you choose a career path that you have a passion for, something that you like. If you really like this lab and you like what you were doing in terms of designing and building bridges, that'd be great. A second part of that equation to help you make an informed decision is doing some research on some homework on what type of salary, what type of compensation would I get if I were to pursue a career in this field? And that's one of the reasons that we are providing this information to you such that you can make an informed decision. Let me take a pause right there and see if anyone has any questions related to careers in bridge building. Monica, let me know if you see anything put in chat or any hands raised with regard to questions related to bridge building.
I will let you know if a question comes in, Jerry, so you can keep going.
Sure, okay. All right, I just wanted to quickly show you, I talked about the fact that I am an electrical engineer and I work for a company by the name of Con Edison in New York City. And I talked about the fact that in addition to the traditional ways in which bridges are utilized in terms of vehicle traffic, pedestrians, bikers, this is a bridge in New York City. It's actually the Queensboro Bridge. It connects the island of Manhattan to Queens. And you can see it's a pretty large bridge. And you can see right under it is the East River. So it traverses the East River. On the underside of this bridge are actually cables that transmit electricity from one part of the city to another. It actually transmits electricity from Queens to Manhattan. So the customers in Manhattan, there are power plants, generating stations in Queens, and the underside of the bridge is used in transmitting electricity over into Manhattan. I wanted to show you another one, another bridge in New York City, the Williamsburg Bridge, another bridge that connects the island of Manhattan to another part of Queens. And you can see in the picture, the roadway on the left-hand side of the screen, but also very importantly, train traffic. This is the New York City subway, the J line, which actually traverses the Williamsburg Bridge. So there are many different uses for bridges, very, very important in our economy. And now this is our final slide. So this is kind of a summary of, different points, different topics related to the topic of bridge building. And, as you can see on the left-hand side of the screen, if you're really interested, if you have a passion for bridge building, different areas, different topics that you could do some additional research on. You could do some, a search, bridge design, tunnel design, construction materials, concrete and steel rebar, lattice work. And then over on the right-hand side of the screen, a summary of the various engineering disciplines that I previously talked about if you wanted to pursue a career.
Well, I'm going to hop in here, Jerry, because we have 2 minutes left. So I just
Sure.
want to say first, thank you, Jerry, for leading such a great wrap up. Thank you to all the students who wanted to share and for Mr. Lynch for hopping in there and sharing, even though his students weren't in the classroom, they were at lunch. Want to say, please, we put a link in the chat for your exit tickets. Please don't forget, we love to hear your feedback and it's important that we get your feedback on this lab and how your special lab day went today. We do have our next special lab day next week for machine learning. And I know that some of you are going to be part of that and we can't wait to see you all again. But for right now, I want to say thank you to all the presenters today, all of the teachers, all of the students, and to the ET staff who are here to make this all happen. Thank you so much. I hope you all had a phenomenal day and we can't wait to see you again for your next lab topic, everybody. Thank you all.